Hi, today I'll be solving problem 10.4 in UGURAL. So we have a simple beam basically, which is rigid at one end and has a point load at the other. And we're asked to use Castiglione's theorem to find the vertical deflection and slope at point A. We're told that the distance from here to here is L. So basically, first thing we have to do is cut the beam and find the moment at that section, or at that cut. P. We have m of x here. This is where we cut, and this distance becomes x. So simply by solving the moment at the cut, by setting it equal to 0, we can solve for a moment. So we'll have minus px, this distance traveled p times x, plus m equals 0. We get the moment to be px. And to find the deflection at 8, we're just going to have to use Castiglione's theorem, which states that delta A is equal to delta U or delta P, which is equal to 0 over L, 1 over EI, M, delta M over delta P, dx. In this example, we could also have added the shear component, but the answer would be basically very minimal if we do add it compared to if we do not. So next thing is we found our moment. We're going to have to find delta M over delta P. So which is equal to minus, which is equal to x from here. Derivative of M with respect to P. So we're going to integrate it from 1 over EI, M, which is px, times it by x, which is dx. We're going to get it equal to 1 over EI px cubed. When we integrate, it's going to be from 0 to L. Sure, we're going to get 1 over EI PL cubed. So the deflection at A is equal to PL cubed over EI. So since it's positive, the point late is correct. It's going to go downward, the deflection. So now we're going to solve for the slope at point A. What we're going to first have to do is add a fictitious couple right here. We're going to name it C. So we're going to go ahead and take another section. So we're going to cut it again. And we're going to add C. Fictitious couple right here, C. We have our point load, P. And I'm going to add the moment, M of x. Again, the distance is x. We're going to solve for it. The moment, summation of moment at the cut is equal to 0. And we're going to have M of x minus px minus c is equal to 0. M is equal, of x is equal to px plus c. So to find the rotation, we're going to use Castiglione's theorem again. And this time it's going to be delta u over delta c, which is equal to the integration of m, the derivative of m with respect to the couple, which is the couple that we had, dx. So I'm going to plug in our moment, so px plus c. Sorry, this is over EI. Px plus c, 1 over EI, so the integration over EI from 0 to L. So the length of the beam, and derivative of M with respect to C is plus 1. So 1 dx. Once we solve, we're going to have 1 over EI outside. We're going to have px squared over 2 plus cx from 0 to L, which will equal to 1 over EI PL squared over 2 plus CL. So since we added the virtual couple at C, we're going to have to set it equal now to 0. So we're going to set C equal to 0. Couple. So we're going to have our slope at A will be PL squared over 2 EI. And since it's positive, it means our assumption that it was counterclockwise is correct. In the next question, I'll expand on this by adding distributed load on the beam as well. Thanks.